This is the logic of a route map. Now, route maps can be made up of one sequence or a whole bunch of sequences. But within those sequences, we're going to find match statements. And then we'll also find set statements. So what we're trying to do with a route map is match traffic or match routes and then perform a specific action on them with the set statement. Now, you don't have to have a match and you don't have to have a set. However, if you don't have a match, it means that everything matches. That's right, everything matches when no match condition is put in a sequence. If you don't have a set, then nothing's going to occur based on what you have matched. So if there's any default parameters or values for that particular network or route or traffic, then the default values would apply. So as we're looking inside of a sequence within a route map, we're going to find those match statements. So let's say a very first match statement we find is a match. So it matches the traffic or it matches the route we had specified in a prefix list as an example. Then what is that particular sequence? Is it a permit sequence? Yes, that means redistribute. So permit sequences mean redistribute. And if there's any set statements, apply them. If it's not a permit sequence, meaning it's a deny sequence, then it means to filter the route, meaning do not redistribute it at all. Do not redistribute it at all. Now, we can have multiple match statements within a sequence. If the match statements are side by side, or not side by side, pardon me. If the match statements have multiple entries in it, for example, if we said match IP address prefix list and we specify a prefix list name and then another one and another one, that means match this prefix list or this prefix list or this prefix list and so on and so forth. So that's the OR logic. However, within a sequence, if the match conditions are on top of each other, so we have the first match condition, then a second one, and a third one, well, then it's this, and and so on and so forth. So we'd have to match all of those within the sequence for it to be a perfect match. However, if we have our first sequence and it's not a match at all, well, then we look at the second sequence and we look at the match statements inside that second sequence. Does it match? Yes or no? Well, if it does, is it a permit or a deny? If it's permit, redistribute. If it's deny, do not redistribute. Well, then what about if it doesn't match at all? Well, then keep moving down. So we're going to keep going down through each of the sequences until we find what? Until we find a match. What if we don't find a match? There's the implicit deny all at the very end of our route map sequences. So let's say your route map's made up of 10 sequences and the traffic or the route doesn't match any of those sequences. What happens? It matches the implicit deny all invisible sequence at the very end. You can't see it, but it's there. And what does that mean? It means you will not be redistributed because it's the deny. It's a deny sequence. And deny sequences mean do not redistribute. So it's very important to understand this logic for redistribution. A permit sequence means redistribute. A deny sequence means do not redistribute.